Here we go. Okay. We got this function, r of x equals 2x plus 4 times x minus 5 divided by x plus x minus 2. This numerator is a polynomial, right? You could graph that polynomial. We're not going to do that, but the denominator is a polynomial, okay? Okay, well, if you look at the numerator as a polynomial, what can you tell me about the graph of that polynomial if you're just graphing the numerator? Well, you can tell me it would be 0 when x equals 5. You can tell me it'd be 0 when x equals -2. Okay. Well, what we do is, the question I started with, for what values is the numerator 0? For what values is the denominator 0? Well, numerator 0, you write out the fact that the numerator equals 0. You write the numerator and set it equal to 0, and you solve that equation. I recommend you solve that equation as I've done here rather than just doing it in your head, because the equation you get might be a lot more complicated than either of these. And you have to know that you separate this out into two equations and do that formally. If you're not doing that, you're not reinforcing it, and you're unlikely to remember to do it when you really need to, when it's not as obvious, okay? So I keep emphasizing you need to write these things out the way you see me write them out. There's a logic to it that you need to understand, okay? Now you probably get by, if you understand just how to do it by inspection, but you're going to be at a disadvantage on some problems in the tests and exams, okay? If you're not writing it out in detail. So anyhow, we write it out and we find that the numerator is 0 when x is -2 or when x equals 5. Well, if the numerator is 0 and the denominator isn't, then the whole thing is 0. If you divide 0 by something that isn't 0, you get 0, which means that you're going to have a 0 when x equals -2, and you're going to have a 0 when x equals 5. Now you see this blue graph. This is the graph of this function, but how in the world do we get to that? Well, we start by getting the x-intercepts. Notice that I label those. I label the line x equals -2, and the line x equals -3, and the line x equals 2, and so forth. Try to get you in the habit of using those dotted lines with the assignment I gave you weekend before last, and they all did quite well on, okay? So yeah, try to do that. You see a lot more information if you've got those lines in the graph. Okay, then we find when the denominator is 0, and that occurs when x equals -3 or x equals 2. Now we write that out and we break it into two equations and stuff, but I just used 3 dots here because we do it the same way we did this, okay? Then we get x equals -3 or x equals 2. Now, x is plus 3 is in the denominator. It means you've got like a 1 over x plus 3 in this function, right? Reciprocal x plus 3. What's reciprocal x plus 3 tell you? Reciprocal x plus 3 is which toolkit graph? Okay. Well, it's your reciprocal graph. Okay. Shifted 3 units to the left. All right. So this 0 that we get from x plus 3 is going to give you a vertical asymptote. I use a light solid line here. And you see that when I get the final graph, it acts like the 1 over x function close to this line, doesn't it? Except the 1 over x function is flipped over because it's got a negative coefficient, okay? It's a vertical stretch and a reflection across the x-axis of the 1 over x function, okay? Vertically stretch it, but whatever all the rest of this stuff is, when you let x equals 3, and reflect if necessary, and then shift it left. So right there is just your 1 over x plus 3 function. It's not hard to see the x plus 3 function. It's not hard to see how what we get along a strip close to this x equals -3 line looks a lot like a reciprocal function, okay? And then same thing at x equals 2, okay? When x equals 2, this is 0. So it's like we got a reciprocal function shifted 2 units to the right and maybe reflected and certainly vertically stretched. And there it is. Okay. So our polynomial that we would get if we graph this, which would just be a nice smooth polynomial, gets these asymptotes inserted into it, okay? And it's also divided by something here. If x is a really big number, then this number is just pretty much 2x, and this number is pretty much just x. If x is a million, this would be 2,000,004, right? Now, if I said, I'm going to give you $2 million, or I'm going to give you $2,004, depending on the flip of this coin, are you going to get all upset about whether that comes out heads or tails? $4 out of $1 million, it's pocket change. It's irrelevant. You're not even going to think about it. Just walk away, say, great, just put it in my account. Okay. Whichever way it comes out, I'm happy. Okay. So that's like 2 million. That's like a million. That's like a million. That's like a million. A million divided by million is 1. 2 million divided by million is 2. 2 times 1 is 2. Meaning that if x is a really big number, that this is going to come out real close to 2. So we put a line for y equals 2. Okay. This is why y equals r of x is going to equal 2 when x becomes big. Either positive big or negative big doesn't matter. If x is a big positive number, all 4 of these are positive. Big negative number, all 4 of them are negative, and 4 negative still gives you positive. So you got this y equals 2 line here, and now you just got to fit it. You got to be asymptotic to this horizontal line, asymptotic to this vertical line, and there's nothing else that goes on to the left of this asymptote, so you just slop it down there. It's asymptotic here, it's asymptotic here. On this side, it's got to be asymptotic to this one. It's got to go through this point, and then be asymptotic to this one. And it just does that. Okay. On this side, it's got to go through this point and be asymptotic to y equals 2. So there it is. Now, it's not simple, doesn't it? It's not simple. It's one of the harder things we have to do in this course, which is why I just wanted to get your brain working on it just a little bit. Okay. Try to understand what I just told you. And then, if you want to take a look at that video, well, you may. If you think about it a little bit in advance, it's going to be easier when we get to it, because I think it'll be due like next Tuesday. Okay. And we'll talk more about it next time. What I'm asking you to do for a quiz here, sketch this picture. Got 4 points here. These are the only points your graph is going to get to go through the axis, any axis. Can't go through an axis except at one of these 4 points. And it's got to have down behavior on this side, the long run behaviors toward negative infinity on the left and toward negative infinity on the right. Okay. Sketch a graph that does that, and then show me the equation. Oh. Numbers on your intercepts. Sketch a graph, and I'll even tell you there are 2 different ways it could be sketched. You have 2 choices when you get to a certain point. Follow function y equals p of x, write the equation for that function. If you can do that, you got a pretty good handle on most of the polynomial stuff. Okay, so what I saw looks pretty good. I'm going to let this point be -6, 0. I'm going to let this one be 2, 0. And I'm going to let this one be 0.50. I'm gonna let this one be 0.386. I can use any numbers I want. I don't have to use an easy number. Whatever number you use, you're gonna use the same as I'm gonna use a 386. That's no big deal, okay? Just means that this is gonna have really big values in order to be that big one to get here. So how am I gonna draw the graph? Okay, well, let's vote. I've got to come up through here, down through here, and then I've got to get this point, right? If I come down here and come up and get this point, I can't go through because I can't get through the x-axis, and I got to go down. Okay, and saying that the camera's not picking all this up, but again, I come up from here, I got to go through here. If I go through this one, then I've got to come up and turn around here, because if I've gone through here and I'm down here, if I go up and go through this, I have no way to get back, because I can only go through the x-axis at the points we specified. All right. So one way to draw it is like this: come down here and come around here and come down here, right? Another come up and come down. Do we understand? So I can turn at this point, or I can turn around at this point. So let's vote. Everybody vote now. Make up your mind which point you want me to turn around on. Okay. Okay, so how many of you want me to turn around here? How many want me to turn around here? How many of you didn't vote? I know who you are. Okay, now. Okay. Okay, but I got more turn